When working with LLMs, a chain of thought is often beneficial for many problem-solving tasks. A chain of thought helps the LLM reason step by step from a problem through its solution. However, a chain of thought is typically rather verbose, which increases the length of the text generated by the LLM. Longer LLM output means higher total cost, longer response time, and greater energy consumption. However, there's also a prompt engineering technique to reduce the length of an LLM's output. With concise prompting, we instruct the LLM to be concise in its response. This decreases the length of the LLM's response, which in turn reduces total cost, response time, and energy consumption. So now we have a dilemma. We want the problem-solving power of chain-of-thought reasoning, but we also want the cost savings of a concise response. This naturally leads to the question, can we combine chain-of-thought prompting and concise prompting to create a concise chain of thought? More importantly, will conciseness decrease the LLM's performance on problem-solving tasks? Hello, I'm Matthew Renze, AI researcher consultant and graduate student at Johns Hopkins University. In this presentation, I'll discuss our research on the benefits of a concise chain of thought on problem-solving in large language models. Chain of thought prompting is a prompt engineering technique that instructs the LLM to reason through a problem in a step-by-step manner. There are two main implementations. Zero-shot chain of thought instructs the LLM to think step by step. Few-shot chain of thought provides examples of prompt and response pairs where the solution contained in the response is written out in a step-by-step manner. Chain of thought prompting has been shown to improve LLM performance by up to 80% for certain types of problems. However, this performance increase comes at the expense of increased response length and thus resource costs. Concise prompting is a prompt engineering technique used to reduce LLM response verbosity. It also comes in two forms. Zero-shot prompting instructs the LLM to be concise in its response. Few-shot prompting provides example prompt and response pairs with the response written concisely. Concise prompting has been shown to reduce LLM response length. However, there is evidence that it may also reduce performance on some problem-solving tasks. A concise chain of thought combines the power of chain of thought reasoning with the efficiency of concise prompting. The goal is to create the shortest possible response that leads the LLM's chain of thought to a correct solution. During our literature review, we only found a single paper that explored creating more efficient chain of thought reasoning. The authors attempted to decompose a chain of thought into separate symbols, patterns, and text to determine their individual contributions. However, the authors withdrew their paper before publication due to technical issues. We were unable to find any other research attempting to improve the efficiency of chain of thought reasoning by making it more concise. So, our specific contribution to the existing research is to explore the intersection of chain of thought reasoning and concise prompting. For our experiment, we evaluated two large language models with 3 types of prompts on 10 exams spanning various problem domains, answering 1,000 problems in total, 10 times each for a total of 10,000 responses for each model and prompt combination. We used 2 of the most popular LLMs available at the time. This included OpenAI's GPT 3.5 and the more powerful GPT-4 model. We used 10 popular multiple-choice question-answer benchmarks for LLMs. These MCQA benchmarks covered various problem domains including math, science, law, and medicine. We used a set of 3 prompts for comparison. These included an answer-only prompt that simply had the LLM answer the question, a chain of thought prompt that had the LLM think step by step before answering the question, and a concise chain of thought prompt that instructed the LLM to think step by step and be concise in its response. We started with an answer-only prompt. It instructed the LLM to answer the multiple-choice question using a specified answer format. We also instructed it to always answer with one of the available answer options rather than answering none of the above. Next, we created a chain of thought prompt by adding the instructions shown in blue to think step by step. Then we created a concise chain of thought prompt by adding the instructions be concise, also shown in blue, at the end of the prompt. We also provided the LLM with an example prompt and response pair to help it better understand the instructions and the expected output. Here we have our example problem used for all 3 prompts. The answer-only prompt was provided an example solution with only a correct answer in the specified format. The verbose chain of thought was provided an example response that contained a step-by-step solution to the problem. Each step of reasoning was explicitly spelled out and no abbreviations or common linguistic shortcuts were used. And the concise chain of thought was provided an example solution that combined minor reasoning steps while preserving only the most important steps. Each reasoning step was also written using a more concise and succinct language. To answer our research question, we compare the response length of the two chain of thought prompts. On screen, we have the comparison for GPT 3.5. On the x-axis, we have the two chain of thought prompts, concise chain of thought and verbose chain of thought. On the y-axis, we have the response length in number of tokens from 0 to 350. As we can see, the response length is significantly shorter for concise chain of thought versus verbose chain of thought. We saw a similar statistically significant decrease in response length for GPT-4. However, when we compare the accuracy between the concise and verbose chains of thought, there is no difference in accuracy. The same is the case with GPT-4. Note that the median accuracy is 1.0, making the notches in this box plot a bit more difficult to interpret visually. But if we add the means to the plot in green, we see that the difference in means is negligible. To further support our findings, we compared response length by prompt type grouped by exam. Here we have answer-only, concise chain of thought, and verbose chain of thought prompts plotted in order along the x-axis of each subplot. As we can see, response length decreased significantly for all problem domains with GPT 3.5. The same holds true across all problem domains for GPT-4. We also compared accuracy by prompt type grouped by exam for both models. Here we have the results for GPT 3.5, and this is where things get a bit more nuanced. We saw non-significant changes in accuracy for most problem domains. However, there was a decrease in accuracy for the two math exams. With GPT-4, though, we didn't see an obvious decrease in performance in any problem domain. In fact, the only place where either chain of thought prompt technique made any difference in accuracy was the math exams. For the two math exams, both chain of thought prompts outperformed the answer-only prompt. However, the two chain of thought prompts performed equally well relative to one another. Given that the math exams were the only problem domains where we saw a significant improvement in accuracy, we decided to do a more in-depth analysis on just the math exams. Once again, we have response length by prompt type on just the two math exams for GPT 3.5. We see the same statistically significant decrease in response length that we saw before. We also see a similar decrease in response length on just the math exams for GPT-4. So our concise chain of thought is reducing our response length and thus our resource costs as expected. However, in the case of GPT 3.5, we see a statistically significant decrease in accuracy on the math exams. So our reduction in resource costs is coming at the expense of accuracy, which obviously isn't good. But for GPT-4, we don't see a statistically significant decrease in accuracy. Rather, we only see a 3.5% reduction in accuracy, but it's a non-significant difference with a p-value of 0.17. And note that I've added the arithmetic mean accuracies to the bar plots in green for clarity. Finally, to determine potential cost savings, we compared the cost of using concise chain of thought with verbose chain of thoughts with both GPT 3.5 and GPT-4. Using the concise chain of thought instead of the verbose chain of thought led to a 21.85% reduction in cost for GPT 3.5, and concise chain of thought reduced cost for GPT-4 by 23.49%. There were several limitations to this study. First, we only evaluated two LLMs and we saw different results for both, so we can't generalize our results across all LLMs. Second, we only evaluated 3 prompts, one answer-only, one verbose chain of thought, and one concise chain of thought. There may be other variations of concise chain of thought prompts that might perform better than our results. Third, we only evaluated 10 problem domains. Concise chain of thought might perform better or worse on other problem domains outside of those we tried. And since the correct answer accuracy on many exams was saturated near 100%, our results might have been affected by a ceiling effect. For future research, we recommend additional experiments involving more proprietary and open source LLMs, more variations of concise chain of thought prompts, and more problem domains. Also, we recommend a more in-depth error analysis to determine which specific types of problems are positively or negatively impacted by conciseness in a chain of thought. Finally, I'm happy to report that a group of researchers in Italy have found similar results in a separate research study currently in preprint as of July 2024. Their study investigated concise chain of thought prompts, which they referred to as constrained chain of thought. Their study involved 5 open source LLMs with 7 prompts of varying degrees of conciseness on a single math exam with 8,000 questions. They found similar results in the sense that prompting for conciseness reduces output length. And some, but not all LLMs saw a minimal reduction in accuracy when using concise chain of thought prompts. In fact, some larger models like Llama 270B actually saw an increase in accuracy with concise chain of thought. In this research study, we empirically investigated the effects of a concise chain of thought on problem solving in large language models. Our results indicate that concise chain of thought reduces response token length by 48.7% on average. GPT-4 incurred no statistically significant performance penalties on any problem domain. However, GPT 3.5 incurred a 27.69% reduction in accuracy on math exams. On average, conciseness reduces cost by 22.67%. So, we recommend you use concise chain of thought for GPT-4, but don't use concise chain of thought for GPT 3.5. And for all other LLMs, you'll need to test them individually. Fortunately, we've made all of our code open source so you can easily run your own experiment. To learn more, please see our research paper and GitHub repository.